All right, so welcome to today's class where we will start from where we left off in the last session. So this is a introduction recovery. This is introduction from NumPy where we left off the other class, and today we will be resuming from array NumPy attributes. So you see how it is. Before then, hope I'm audible enough. Can you some reactions? Let me know if you are hearing me.
Yes, can you?
All right, all good. So we left off from NumPy data types today, and today we'll be resuming from the NumPy array attributes and going down to where time will permit us to stop. So I'll get my and just a bit overview to explain what that means, although you see more of that when we get to experiments. So in NumPy, attributes are properties of NumPy array. So you cannot talk of NumPy and leave arrays and leave what's numerical operations out. Of course, I make mention that NumPy is short for numerical Python. So yeah, so it's the properties of NumPy arrays that provide information about array shape, or my notepad, about array shape, size, data type, and dimensions. So, and for that to be using this function ndim attributes, this ndim attributes, which means NumPy dimensions. So there are numerous attributes available in the NumPy, which we will get to explore them as we proceed. But just to mention, we have this which returns, let me do something like this, which returns the dimensions of the array. Yeah, I'm very.
I know I've been complaining about it, but I think the noise is too much. We can't hear you. Their voice is overshadowing yours.
Did I not enable that? No. Okay. I just have to try and be audible. So the size returns the number of elements in the array, the actual, to be precise, actual numbers of elements in the array. I'm doing this just in case you need it. So, and another one is which one? We have the dtype, which we talked about. I will not want to say more. Of course, you know that the dtype returns the data type of elements in the array. We will be looking at shapes today. We'll be looking at shapes today, and the shape returns the size. It's returns the size of. I think this time will take time, so I'll just try and be detailed about explaining it. So the shape returns the size of the elements in each dimension. Elements in each dimensions. There are lots. Then we have items. That is spelling item size. Item size, which this one is very important. It returns the size. The size, but this time around in bytes. The size in bytes of each element. All right, and of course the data, which returns the profile. We look at it, still memory related, of the actual elements in the array. Okay, so we'll be looking at all of these and others. So these are just some of the attributes that NumPy has, and to access them, you have to use this, the dots. You have to use the dot notation. You just have to do this because I'll be a bit fast and I'll be explaining the code. For example, maybe I could say, let's say this is my array and I call it my name. So I want to access one of these attributes. So I'll use this variable, my name dot what's maybe data size, right? The data type, and you do whatever you want to do with it. So this, of course, returns the data type of that. All right, so let's go. Buffer. Now the buffer has to do with the memory, so we get to see more. Where is it? It's memory related, so I'll talk about that when we are resuming. I needed to just list this so I don't forget any of this. Where did we even talk about the buffer? That is the data, right? Okay, so our imports. Our import statement first. Then we could make an array and assign that to. Of course, we have to invoke our NumPy. Then we create our array first. The array function. All right, and maybe anything if that's 3, 5, 6. Let me leave it at 4 or 3 before we proceed. And maybe 1, 3, 27, 7. All right, I'm having error from where? If not, I would rather run it. The error message will guide us to what that means. This is this. Okay, so this is, since this is a 2D array, people should be calling my attention to this. I just said I've made one, so I have to add another square bracket to that. So this complement this complement this, and this complement that. Any more the error message you guide
What's
us.
that comma? That comma after, sorry, that comma after 5.
Yeah, exactly. The error message should have still guide though. Okay, we still have it.
So
Let's wait
why
to.
this?
Okay, so let's make a check of that to check the dimension of the yeah, just to add, I push this to GitHub, so most of the comments I'm adding to help who will be looking at the GitHub, and maybe after the call I'll be sharing the GitHub link. So this is the one for yesterday, and I push it. So that is the need why I'm adding this array. And when you are going through it, this will help you to understand. So Prince array. Then what did I say we used to access the individual attributes, the dot notation, and what you call the attributes you want to call. Of course, this has already suggested it for me. Okay, so let's go over it again. Maybe during the course of going over it, I'll see while the error was there. So in this example, I use these attributes, this ND, which is ND dimension, that is just to check the dimension of our array. So this is what this attribute does. And of course, I made mention that it returns the number of dimension present in our particular array. For in our case, this is our array variable. And I'm using a tool, D array. Okay, so this is my syntax. The first one complement is 2, 3, 5, and this telling me that one of it is not close. The error message will guide me to which one, as I can't really see this one complement this complement this, and this, so it should be close. Okay, at this line 13, perhaps I forgot a comma. No?
After
Yes,
13.
truly. Yeah, I forgot a comma. Tell you the error message will guide me. So comma there and everything is fine. Okay, so the output is 2. So this 2 now is telling me that, of course, you know what this does, that it returns the number of dimensions present in our array. In this case, ARR is our array. I call it this way. And it's telling us that, yes, the number of dimension present is 2, which is this. So if I hit a variable for visualization, you will see it's loading. When it's out, you should see it should be displayed here. Okay, so which of them is next in the list? The size, and the size is on the actual number of elements in the array. So let's go check that out. Get a text message. The size attributes. I want to bold that. So I'll get this. And just the same thing, maybe my name this time around, UD, and I'll assign it. Of course, you don't forget this line. Everything has to do with array, np.array. Okay, so sorry, square brackets. Let me make it now before I will start. So today I will say maybe 1, 3, 4. Okay, let me stop there. Then open that. I'll add a comma here outside. Enter, make another square bracket and call 6, 8, and anything to. Okay, so this will set the stress. So for your sake, if you want to do this, you can do this at the same time, just to mix up the data. Then you go inside and create another one. So this one remains it. You have your first array here and all of that, blah blah blah. So you come out of it, add comma, then another array to complement that. So that is that. So print. I'll print what? Then I'll use the dot notation, don't forget, and I'll call my variable which stores the array. So if I save and run, so why are we adding 6? Of course, we saw that the size returned the actual or the total numbers of elements in the arrays. So regardless of the numbers of the dimension, it does not regard the dimension, but it returns the numbers, the total number we have in the array.
Sorry, you didn't drop a comment to explain what we just did before print.
Come again, sorry. Before
you didn't drop a comment to explain what we just.
Okay, so this returns, of course, you know what it does now. So it returns the total number, my use of English, number of the array. But in this case, our array is what? UD. All right. Okay, so next I'll have to get text, and next in our list is, I think that was shape, or whatever it is, we do it. So we talk about the shape. The shape attributes. I'll bold that, then I'll get a good cell. So this shape, from my explanation, this shape where returns the words, returns a tuple. All right, we get to see it, but this one I'm using tuple because I'm trying to relate it to previous class that we've been doing. So it's going to return a tuple of integers that give the size of the array in each dimension. It sounds like a rocket science, but we see it from here. It's very simple. So I could say this was UD, so I could say UD1, and I will, of course, sign it np dot array. You should be familiar with this syntax now. Let me still maintain my 2G. All right, so maybe 1, 2, maybe 5 come out of it. See this method now as really status, and I could say 6, 8, 5. Okay. So let me add comments this time around. So of course it will return a tuple. Don't forget, return a tuple. That's, this comments is what you want to explain it. So however you want to put it is is for your choice, is left for you. So what does this do? It returns a tuple that gives maybe give the size of array, and this time what is our array? UD1 in each dimension. Okay, so I will print UD shape. Or there's another way you can do this. You can pass this to a variable, then print the variable. Trust you know what I mean. You can pass this to a variable, then you print the variable. Like this. This is what I mean. It should work. So you could say maybe Sandra. It's the Sandra and the call. Sandra is equals to UD1, right? Dot shape. Okay. So if you print Sandra, it's going to give you the same thing. But let me comment that out and go with this. So if I save, it return a tuple, have you seen, that gives the size of array in each dimension. So it's telling you, yes, that we have a two-dimensional array, a 2D array, each with what? Three elements. So to make it more standard, we have 2 rows, each with 3 columns, right?
Yes.
Okay, beautiful. So we look at the dtype. I think next is look at this yesterday, right? But let me just add one example to that, just to save the recording. We look at dtype. I will just I saw blow run the call. Blow equals to mp dots array just a very simple. Let me make a one this time around. We talked more about this yesterday. 7, maybe 2. Then what do I want to do? Nobody's saying anything. Go. Okay. So print. Do I see any? Let me add comments for those who need to. So it will check the data type of glow. So it will check what data type this is. So a variable is blue. So I'll print it. Print glow. Then the dot notation, and we access the attributes. Dots data type. So for my machine, of course, we did this yesterday. So my own might be my own machine architecture is int64. So it will give me int64. Yours might be int32 and all of that. We talked about this a lot yesterday. Even had to change data type. So int34. Okay, so next, I think what is next? Next is the item size. And what does it do? It returns the size in bytes of each element. The item size attributes. Is that is one of attributes? I'm not sure. The way I'm forgetting spellings is this. Okay. Okay, so I'll have to get the code cell So promise on the call, promise, and I'll assign it to, first of all, we create our variable, our array. I want to use a 1D array this time. So since we are looking for the item size, let me make it much. It's 5 or 2, 1, 7, and all of that. It will give you the size depending on how many elements or items you have there. So let me do something now. Watch what I'm doing. And I would say promise 1 np array So all of this that we have here, I will not want to wait. Let me bring it in. All of this item. I will paste it here. Then add a comma here. And I'll call our dtype. np dots, let me change that to 32. Okay. So Glory, let me add comments here before you call me. So let's say, what did I do here? I create a 1D array, 1D array of, since I changed it to you, let me say of 32 bits, 32 bits integer. All right, so that is that. And I want to use the item size now. I want to use the item size attributes. Item size attributes to determine what? The size. Determine the size of each array element. Now, which one? Array element of what? I want to check the size of array element of pro 1, promise 1, and promise. All right, so let's go ahead and do that now. So I'll print it out. Promise, the dot notation, and the item size, and row 1, the dot notation and the item size. So is there any error? I don't think. If it is, the error message will guide us. Okay, just to go over it. So pro1 is an array containing, for my own machine architecture, a 64-bit integer. You'll see this in our output by default. Of course, I told you that 64-bit integer uses how many bytes each? 8, and 32 uses how many bytes each? 4. Don't forget. Which by default, this 64-bit integer uses 8 bits of memory per element. So this time is 8 bits. 8 bits, 8 bits. So each of them is 8 bits. So now this item size now will turn 8 bits as the size of each element, right? Now in this one, I've made it an array of what? 32 bits, which I've changed the data type now. So each element in this array we use only 4 bytes. This other one now, 4 bytes. What am I writing? 4 bytes, okay, of memory. So for now, this item size attributes will return 4 as the size of each memory. Let's see. Okay, so 8 and 4. Always remember here in this inspector to visualize what we are doing here. And yeah, Glory, you talked about the next is the data where you asked about the buffer. I'll get my text cell, the data attributes. Attributes. So we can get the buffer containing actual elements of the array in memory using the data attributes. Now, in simpler terms, the data attributes is like a pointer. I'm trying to explain what I mean. So it's like a pointer to a memory location. Okay, where array is stored. So where the array data, each of these can call it a data where array data is stored in computer memory. You understand more with this. So let me create we have. Okay, so let me use this at 3 and I'll assign it to first you create your array. Then I could say 4, 7, and 2. I could have 4 and I will say np dot array square brackets 1, 2, 4. Okay, so let me say not curly braces but square. Okay, so I could say 5. Let me bring in my first action items 4, 7, and 2. This could throw an error at us. I forgot this and nobody called my attention to it. This should complement it. All right, so what it's doing here, let me use a comment to explain what it does. So I want to print memory address of arg. And the second one, arg4. So print I should add a new line, make it a bit descriptive. Data of arg3 is this. So I'm having this because I should have a string here. People should follow so that you'll be calling my attention to this, please. Okay. So I'll call arg3. Then how do we access this? We use our dots notation and we call it the arg3 dots data. I'm seeing a warning there. I'll come back to what that warning is doing. Okay, so data of arg4. Then I will call arg4 accesses using the dot notation, and I will call the data attributes. Okay, we are having one warning here. Why? Yeah, because we are having arg3, but I'm having r3. So I'll take that off. And what this does is that here this data attribute will return the memory address. Let me not even say address, the memory addresses of the data for arg3 and arg2 respectively. So let me save and run. Okay, so data for this is at this memory, it stores at this memory, and this it stores at this memory. So just to go back to this again, so what this does in simpler terms is that it is like a pointer, okay, so which points to the memory location where the array's data are stored. All right, so this is this, you may run it from your machine and you may possibly don't have the same output with me. So let me run it again. You see that it has changed. Run it again, it has changed. So that is that. Am I still connected on the call? Everyone is just so quiet. Okay.
Yes.
Any question?
Yes, I have a question.
Please go ahead, because I was wondering why everybody just so quiet.
All right. In this print line, why didn't we put the F? Why didn't we use F because of the statement we're making?
Why didn't I use what? You mean the F string?
F.
Mean the F string?
Yes.
Okay, so it's a matter of choice. Of course, you know, if I'm using the F string, I will have to produce this data. So I think I did something where I made it two-way, but I decided to, since standard or shape, yeah, I did something like that. So there are different ways of achieving that. Just for you to know when you're what you're doing and the right contact and the right syntax. Basically, it anchors on the logic. So who else has questions? Sandra is not on the call today. Any problem? Okay, so we are done with this, with all the attributes of NumPy arrays. You know, we saw all of them, and to access it, we use the dots notation and we call each individual attribute. So next, I want us to look at NumPy inputs. This one is going to be a bit tricky, so you have to pay attention. Inputs, outputs. Is that a spelling? What's wrong with me with spelling this? Okay, so we're looking at NumPy inputs, output. So a brief theory about what this does and what it means. So NumPy offers input and output function. For short, you could call it this way. So input output function for loading and saving data. Right, this is another keyword now I'm looking at for loading first. For for loading. To even load, we need to save. So for saving and loading data from files. Okay, so input function supports a variety of file formats. Of course, we'll be looking at it, including the binary, the binary text, and even large arrays. So it uses the binary text to access large arrays. Okay, so these are the formats. It's used binary, it uses text, and you will see more of this. So the binary format is designed for efficient storage and retrieval of large data, and the text format is more of human. Of course, you know, when we talk about this binary now is for computers, your zeros and ones, right? But the text format is more of human readable and can be easily edited in your text editors and all of that. Okay, so the most commonly used functions for NumPy input and output includes the save. I talked about that, the save, and function, you know, you have to do this. So what does this do? It's save an array to a binary file. So it save an array to a binary file. Okay, in what? In the NumPy format. That means for this it will end with extension .npy. When we talk about formats, ends with the extension .npy. So next we have the load function. Okay, and of course it's just like the name implies, it loads data from binary file in NumPy in the same format. So it loads data in the binary file in the NumPy. So what does that mean? .npy formats. Okay, so we have the text formats. So save, and to differentiate that, txt, yeah, that is right, text txt. So this one, what it does that it saves an array to a text file, okay, in a specific format. Save an array to a text txt file. This is text, so I'm using this for short. In a specific format. And of course, we have for load txt. What this one does is that it loads data to a text format. Loads data to a text file. Okay, so let's get to explore each of these individual functions, what they do. So first I will have to get a text cell to NumPy inputs and outputs. So for this, I think the first one we have, I still have to get another text file. So for the first one is the save, and we use these formats. np, the dot notation, np.save. Then this is what to do. What are you saving? You save it to this file. And what are you saving? You save an array to this. This array could be any variable name. Could be UD, could be promise, could be glory, could be X, could be Y. So this is its format. All right, so let's get to see that. So I'll call Sandra and I'll assign it to np dot array. And I want to use a 2G array this time. So 1, 2, 3 will come out. Maybe 7, 6, and 4. And here I want to save the array, which in our own case is Sandra, right? Sandra to a file. And watch what I'm going to do next. It's very important. So I'll have to call np.save what am I saving in a file, right? I could call this. And what was the format of this save? Someone should remind me as I'm doing it. I talked about it now. So I want to save it in this file. And what are we saving? The array in our case is Sandra. Now, if I run this thing now, if I run it, you see that nothing will come out. There will be no output. Why? Because I've not loaded it. Okay. So let me do that. Have you seen no error but no output? Okay. So we can only have output if we call the load function. Okay. So now the load function will now load that save file using let me do that. Let me say load underscore. Maybe let me load Sandra, load San. Okay, equals to np dot load. So here I have saved Sandra inside this file, right? Inside this file.pny. So now I want to load this. We are out of Sandra now because it's saved here. So now I want to load this file. All right. File dot npy. Okay, so after that, I will have to display it using our print statement. I have to display. If you are just joining the call, you have to display the loaded array. In our case, is what? Sandra. Okay. So I'll print load. So we should expect an output here now. Let me say from here, we'll say using the load function. Okay, using the load function. So from there, if it's load, we should see this. First is self, and then it's load. Okay, so that is this. Any question? Are you lost somewhere? Any question? Are you lost somewhere? Okay, so I'll proceed in the absence of no questions. I'll get my text cell. We've talked about this. We've talked about this too, so let's talk about this too. So save NumPy, save tx in the txt formats. And first of that is this self. No need to do that. Let me just get a quick so. And then I'll take this up. Take this up and bring quote cell down. So like I said before, this self.txt function save an array to a text file. And of course the syntax, just like we did before, I think I should even get before then. I should get another text. So this is it in syntax. You call it this way: np dots, the dot notation, then the save, then the file where you are saving it to, the file in a dot what, in a dot txt format, and what's the array, this array is any variable, right? Okay, so this should come down. I'll come to this and take it down. Okay, so it's in order now. Okay, so let me make another array. Am I out of variable name? No. Let me say x equals to np dots. First of all, greet your array. One, 3, 5. The second one, and maybe 2, 1, 4. It's 2, 1, 4. Okay. So what do I want to do? I want to save the array to a file. Save the array to a file. So np dot what? Let me just pick this. So np, this is where we want to save it to, and what are we saving? We are saving our array. Of course, in our own case, it's x. So if I run this just like before, nothing will come out before because I'm saving it. Nothing is out, no error, but no output. Why? I need to load that first. So to load it, I will say load the array. In our own case, our array is what? We move from X to this text file. So I want to load this text file now. That's txt. Okay. So loaded loaded X equals to np dot. How do I access it? From the syntax I gave here. Okay, do not talk about that, but the same syntax, load.txt. So load txt, and I'll print it out. So here I have I saved my X variable, my array X into this file, and I use the load function, load txt function to load the text file. Of course, my text file is this file txt. Okay, that using the save function, this file, I'm loading this file that I previously created using this. So I want to see the output. But yeah, there's one thing you should note, because you're going to see a different output. You have to know that the value in the loaded array will have a dot. This one did not have a dot, right? But the output of this one will have a dot, because loaded txt in this function txt format rates the value as a floating point, okay, by as a float point numbers by default. So you'll not start scratching your head when you see the dots. Okay. Any question? Should I go over it once more? Am I still connected?
Yes,
Okay.
please go on it one.
Okay, so where did we start this one? We are talking about file inputs and outputs, right? And there are some of the functions where we could use to, what basically does is that it's text files, save files, load files in large numbers, right? From our explanation here, right? So it's save file, load file in different file formats. The binary, of course, the zeros and ones, your text, your txt, this one is human readable, you can edit it in text editor. So we use this to access large arrays, not just what we are doing, thousands of arrays. I told you that NumPy came as a result of it being optimized for fast execution as compared to your list that we have been using, your Python list. Okay, so we use these formats, we use these functions, your save, your load, and all of this to access files in different formats. And of course, this one saves an array in it's saved in a binary file. There was an error here. In this format, or NPY, you saw that load, of course, you will not have output. When you save it, you have to load it to be able to print your output. All right. So this one loads data in the binary file of in this format. And save txt, it save an array. Of course, you know your array based on where you assign it to a text file in a specific format, and this loads it. So here we came to experiment that and see for real. So first we use the save function, and this is the format. You use this save np, of course, dot save, you call this save function. Then where are you saving it to? You save it to a file, and what are you saving? You save your array based on the name you give to it. So we saw that here we created our array. In this case, I set my array to Sandra, and then again I save it in this file format. What did I save? I saved this array where we pass to Sandra. Then I'll now use the load function, because as at this time, if you run it, you will not have any output because you only save it. So let's say this load now is a way of retrieving it, if I should call it that way. So I now use what? I now load this file. So we are done with Sandra now because I save it here. So what I'm now looking for is this. So and I now load it and what I display my loaded array. Of course, you saw that it gave us this. So the next format is the txt, the .txt format, which is human readable and can be formatted or modified using the editor. Of course, this is its syntax. You call it, this is the array that you want to save and to any file format. This thing must not be filed, could be sandra.txt, could be promise.txt, but since I need to really portray that it's a file that I'm saving. All right, so this is my array. In this case, I use variable x and I save it to this file. Of course, we are working with the .txt format now. And then again, I use the load function, the load txt, and then again, load this file where was graded here. We first of all graded the file here. So I'm loading it here, and now I want to display my loaded file. You're seeing these dots because by default, it reads .txt file as a floating point definition. So I think I've done justice to that. The recordings will be available. You look at it once again and you get the gist of the concept. So next we'll be looking at NumPy what? NumPy array index. Is that the spelling? Yeah, that is. I'll bold that and we are good to go. Hope you all are doing this with me. Oh. You have to do it, though. I might be explaining it and it seems simple. Oh, that simple thing, you just call the function, you just call the method. But when you get to do it with your hand, that's when you know that it's not that simple. So try and do it with me now. So the NumPy array indexing. Let me get my notepad. Okay, so what I'll do is that I'll be saving this explanation, then I'll send it to the group. So NumPy array indexing. Please, before the class, just remind me to save this and send it. Maybe you need it, or I'll add it to the video description when it's available. So for this, each element in an array is associated with a number, right? We've been doing indexing since when we were doing Python, how to access a particular index, a particular index in our lists, in our strings, in tuples and dictionaries and all of that. So now we are dealing with NumPy. So the number is known. The number that we will be accessing is known as what? Array index. Okay, so I'll be using this often in the course of this subtopic. Okay, so if I will want to what do I draw with? I think there's this online platform where you can draw something. But what I was trying to do is that it has an index. I think is it draw.io? I've not used that for a while. I wanted to draw some. Just show you. Is it? Let me start. Flowchart. Which one is JavaScript? I've not used that before, but I've forgotten the name of the one I've been using. I wanted to show you how the memory is represented. Okay, so let me go back to. So now I wanted to
try paint.
pen.
Paint. Microsoft Paint.
Oh, let me do that. Pen. Is it this one?
And it should be on your system, not a cloud product. Microsoft
No.
Paint.
Paint. Oh, this. Oh, wow, I've not used that, too, but there's this cloud one that I've been using.
Okay.
Which
I just thought this
tool
one would
do
be
I?
custom.
And this, okay, so this is perfect. Let me see. So I'm trying to draw a straight line here, although I'm not so good at drawing. Okay, so this at least you help you visualize what I wanted to do. Okay, so this is just a clear example of how your memory represented. So we could have our variable one. How do I write one? So A and 3A. This is 3. This is 4. This is 5. And this is okay. So we have 6 elements here. And of course, you know that when it comes to do with index, when it comes to do with memory, it's not your usual total number of elements. So of course, this is 0, because it starts from 0. This is 0, this is 1, this is 2, this is 3, this is 4, and this is beautiful 5, and this is 5. So this is because the array indexing starts from 0. So this is telling you that 0 is the first element of the array. This first element, the index is 0. The second one is 1 and 3. So we want to access from the last one. Of course, you know that here is -1, -1, -2, and like that, and like that, like that, like that. So now we will see how we can access individual elements from array using the index number. So if I want to access index 1 now, I will not be using 1. Because if you use 1 and expect to have 1, you are wrong. The output will be 2. So that when I'm doing it, you will not be scratching your head while she talked about 1. Why are we having 2 and all of that? Okay, I'm not too good with drawing. Please let me go to this one. So let's say I want to do array 1. I want to access the first element. Of course, you know what we've been using this is 0, and the next one maybe array 2 is 1, and array 3 is 2. So inside. Okay, so expect this, and the formats for that. Do I need formats? You see it in the code. Okay, so let me get a code cell. Okay, I have one already. So I could say arc1. I will have to initialize my array, assign it, use the array keyword. Let's try to the simple 1D this time. 1, 2, 3, 4, 5. Okay. Now I want to access the NumPy elements using indexing. Okay. So this 1, 2, 3. So I'll be fast in this one because it's what we've been doing. I want to print array at index 0, then print array at index 2, then print array at index 3, print so we have 0, 1, 2, 3, 4. So if now if I want to go to like the fifth one, like you suppose your eyes is telling you that 1, 2, 3, 4, there are 5 items here. You see that we have error. But let me first of all do this, save this one and run. We have this. So if I try this, print arc1 at index 5. Okay, so have you seen error? So index 5 is out of pan for this. So the axis is between 0 is with the size of 5. So it's if it is this, it's between 0, 1, 2, 3, 4. So if you want to assess the fifth element, as your eyes may be telling you, oh, we have 1, 2, 3, 4, 5 items, let's assess the word. So it's only that index 5 is out of bound, and we see that it is underlined here. And they're telling me, oh, it is at this line where I print this. Now, if you can access the individual elements here, you can also change the value, that is modify each index of elements in NumPy array. So for this, I could say, come here, I could say arc1 rather. Then at this index, at index 0, I want to change it to what? I want to change it to do we have 5? I want to change it to 9. Okay. So if I now print, let me comment all of this or take them out. So if I now print array, this you see that here will be replaced with 5. The first element will be replaced with the number that we've modified it to. Okay. Now we also have negative indexing, just like I mentioned. So if instead of this, I want to access modify the last one, which starts from 5. I want to make it 9. So if I save and run that, you see that the last item has been modified to 9. If I change it to -2, run it, you see that we now have 9 at the second to the last element. Okay, so now how can we access a NumPy array? Okay, it's different with different dimensions. We want to access it from different dimensions. Okay, so let me say here, rather let me make arc2 let me just accept this. And arc2, I want to modify something. Arc2. I'm telling it before I even modify it. go through that, and then the first one. So if I now print okay, so what is that? Yes. Can someone tell me what I'm doing here? From the error, the error messages are even listening out. Am I on the call? The class should be interactive because we've been doing this on lists, we've been doing this on strings, tuples, dictionary, assessing individual elements. Ah, good. Okay. Let me do a different thing entirely.
Sorry, can you hear me? I was trying to speak.
Yeah, we're saying something.
Promise.
Okay, go ahead. What is
Okay,
the
so
issue here?
because of the index 2, maybe you would have put 1 instead of 2. Because it is two-dimensional array. So I think it would have been 0 and 1.
Okay, so according to promise, simple as that. You just talk about indexing, my beautiful and prestigious people. Okay, so let's do a different thing here. Let me create another array and I will assign it to here the np.array. I told you people to be prepared for this week. So when I say maybe people thought I was capping, okay? So 1, 3, 4, 2.
Sorry to take you back. So what has this last one you printed done? This array 2 1, 1.
This.
Yes.
Okay, so what about it?
Yeah, I'm asking what has it done? What does it do?
Okay, so this should do something if I have assigned this to anything, to a variable, right? But at this particular line, I'm printing directly. Okay. Is that Gloria or Sandra?
It's Glory that asked.
Now, wait. Let's do something here. I didn't even look at that E and assign it to it should be back. It should even work without printing A, but let's see.
Okay, I think there's actually an effect. It has changed the number 1 index in the second. God, the two-dimensional array, the first one, like that place it was 6, 7, 8. Now it's now 6, 9,
I saw that.
8, 9, 10.
I saw that.
That's why I was asking, what does it do? So I was trying to follow it up from there.
What do we name this array? I'm coming, Glory. Then which one will you be working with? I think the second one or the first one. Promise.
Second one.
Yes, that
Was it
array
the first? Okay.
Array 2.
Array 2.
Okay, for the second array, the items are 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And this array two, not here. So this should have replaced this with 9. The first array with 9. The first array with 9. Let me take away the 9.
No, see what I think is you are trying to, like, you got the first, let me just take it like matrix, like the first like that 1 2 3 4, it's like that 1 2 3 4 5 is 0, like the whole of that thing is 0. The second one is 6 7 8 9 1 9 10, and that one is 1. So now you pick that one, and then the second, there's comma 1 there. You are now in that particular one, you found the second element in that particular this thing. That's what you replaced with 9. So it is now 6 9 8 9 10.
Okay.
Yeah, I get it. I get it now. I get it. Since I left this particular part, okay, yeah, this is it, Glory. I was checking. This is the use of comments. So what I was doing here is to assess this element, and of course, this particular one, this is 0 and this is 1. Okay, so
So you are
if I'm
saying
trying
that row is 0.
yes, that row is 0.
Okay.
Okay, so you're not really seeing the effects because I'm trying to assess the element. But now let me clear the air with this example. Just watch. Let me use this example and explain what this is going on. I will get another array. Okay, so I should add another one here as a guide so we don't forget. Okay, so let's pick our array item 9, 11, 13, and maybe 15. Okay. I should even add another one to make it. Okay, so this one should be here. Maybe 2, 4, 6, and maybe 1. Okay, is our syntax correct? This complement this complement this, and this complement this. Okay. So next, I want to assess the element at the second row and the fourth column. The second row, fourth column. Let's see.
That's 1, 4.
Yeah, let me get another element. Let me say elements equals to UD. Okay. The second row and the fourth column, right? The fourth column should be 3 if it starts from 0, right?
All right.
So if I print that, if I
So
print
you're expecting 15.
save and run that, you now get the logic. Now let me even do something more different from that. Let me change this, maybe to show that this is the first one, which is 0. And let me get the third element in that particular array. The fourth one rather. 0, 1, 0, 1, 2, and 3. Okay, so if I go to 4, it should throw an error at us. Have you seen that? Because we are out of bound, we are out of the scope of this array. Now,
Okay.
if we are accessing the each row, what if we want to access row or maybe column as well? All right. Now, this is getting even more tricky. What I'm trying to say is that we can access specific rows or column, okay, in any ND array. By ND, I mean any type, be it 2D array or 3D array, using indexing. So let's see, let me take this out. Let's see that. Let me get another code cell and we see that. Maybe array 1, if I should call it, and I will assign it, I will assign my array to that. Let me work with even more. Say 1, 2, 3. All right. Oh, don't have a comma here, but rather here. Another square bracket, 7, 9, 2. I have to read, let me use 4. Add a comma here and eight, 7, and 0. Okay, so this is what we have. Now let's access the second row, which is this of the array. Second underscore row. So second row of this array. Not a curly braces, but a square brackets. So I might even do something very tricky. So instead of just the second row, let it get to the end. We did this. So if I print that out, print second row. So from this, from what we have here, this is the first row, which if I added 0 here, you will deal with this. 1 has to do with this, and so the 0, 1, so everything to the end from 0 index, from the 0 row into the end. So now let me access the column now. All right, let me access the column, the third column. So if this is 0, 1, and this is 2, so if I leave here, please watch what I'm doing. If I leave here, and then access the third column, and if I print this, we should have, okay. Do you see that? 3, 4, 0. This is column, and we're talking about row. So this is column 3, 4, 0. So if I have 1 here, we have 2, 9, 7. And if 0 there, I'm just trying to clear the confusion we have from, and if 0 there, we have 1, 7, 1, 7, 1, 7, 8. All right, so I believe whatever glitch was there is now clear. Okay, so if we can do this, okay. Why?
Sorry, my network went off. I just came back now, and I missed when you were explaining this colon part. I don't know if you can just run it over again.
Where did you last me? This particular one. So
Yes, when you're about
we
explaining
talked
how
about
the colon.
row.
Yeah, I understand
Okay,
the rule.
All right, this I am telling you, we're having issues on the indexing, understanding it. So I needed to experiment that. So I think we got these two will give us the third column of what is due. So the result will be 3, 4, 0 with this. So it's telling you out of here. This part was for the row, but we are dealing with the column, row and column first. So I am telling it at column 3. If we start from 0, 1, 2. So come to this column and let me access all the elements in the column. So we ask for this 3, 4, 0. So if I change this to 1, if I change that to 1 and run that, we have 2, 9, 7. And if, of course, I move that to 0, we have 1, 7, 8.
Okay.
So, yeah, so that is that. But let me do something even more.
So the
basic.
colon is being ignored.
This is column that we are talking about. Like this
No,
is
I mean
column. This
in the
row
I mean in the line second row equals array colon dot comma 0.
at 0. Come again. Let me
Yes,
get your
that
question.
colon is that colon being ignored?
This column.
Mm-hmm.
If I have something here, it has to do with the row. I'm telling it come to the second column, the row now, and give me the first element.
Yes, I
Okay,
understand.
so this part is for the row. But if
So
I just
you putting
what?
So you putting just colon in that part that is for row. What does it mean? It means that the computer should not.
Row. We are not dealing with the row again.
Okay.
But we are dealing with the column. All right.
Okay.
We are dealing with the column. All right. So you have to get that because I want to do something even a bit more advanced now. Why is it telling me? Let me delete that. I'll get another code cell. Okay, now let me do this. Let me use you. You have to even pay attention to this. And I will assign my array to that NumPy np dot array. Okay, so I'm going to work with a 3D array this time. And of course, you know the shape for a 3D array. The shape is this. Maybe two. So this is our shape of it, right? Anything here will be not 0. Any number then. So let's go see that. 1, 2, 3. All right, so let me go 1, 2, 2, 3, and 4, right? I'll come out of it. And look at this. After you tell me the shape of this, how it is. Okay, just watch. When I'm done, you tell me the shape. I stop at 4, so I will say 5, 5, 6, 7, and 8. Okay, another one, and I will say 9, 10, 11, and 12. Okay, so that is that, and let's go another way. So here, remember it's 3. We have a step and another one. So 13, 14, 15, and 16. I want to go accordingly, come out of it. Get another one. We start at 16, 17, 18, 19, and 20. So the last one, 21. Before that, we get our square brackets. 21, 22, 23, and 24. Okay, this structure, is it correct? No. No, no, no. We should have another square bracket here and 2. Then to complement this slice, we should have another one there. And yes, another one is here. So wherever we have error, I think it will complement it. This complements this, and this. I think we are missing one, but the error message will guide us either way. That's the importance of error message. Okay, now so let's assess access a specific elements of the array. In our case, we are using glory. Okay, so this is where people will be scratching their heads. So you watch the screen and you owe me question. You have to tell me this shape, what the shape is. So elements equals to glow. What I'm doing, go to the second one, gets me the second, and maybe gets me the so print it out, print elements. That is not the spelling of print, as I'm having one. Prints That's okay. So first of all, what shape is this? From this.
Three-dimensional.
Okay, so how will the shape look like?
3x4.
This is what I mean. This is for simple. So this is for two. This is what I mean by shape. So this part is what I mean. So how is it going to look like? Tell me, let me write.
3,4.
3,4. Yeah, it's 3,4. But the slice, how many slices?
2 slices.
2 slices. So for that, if it's it should be 2,
2, 3,4.
and 4. Beautiful. Thank you for that. Beautiful. We're having warning here. Okay, yes. After 8, we shouldn't have something here. So I guess that is why. So it's gone. I just noticed that. 2, 3,4. And let me not say what this is doing. Let me run it first. Okay, so with this and the outputs, can someone tell me what this line, what's the logic behind this line?
Okay, so it went to the second slice,
Okay,
which is on index 1.
okay,
And then it went to the second row, which is on the third line.
second row.
Sorry, it went to the third row, which is on the
Okay,
second index.
okay.
And then
And then
it
give us
picked the first
elements at what's index 1, right?
at index 1.
Thank you very much. That is that. So it shows you are following and the confusion is off. Who else understood what Glory is saying? Hope others are in the same page with us. Not only Glory. Okay, so what if I add 3 here instead of 2 is 3 here? What do you think will happen?
It will be an error
Okay, why?
because it's for the second it's 0, 1, 2. That's how many rows it is. That's the index 0, 1, 2. So if you give 3, it means it has to be 4 different rows.
All right,
So it's just 3 rows.
Beautiful. So that means you are following. We're supposed to stop by 1, but we are out of time. Let's just do one more and we are call it a day. That one is, it won't take time, so don't scratch yourself. So I think the next one we want to look at, I don't want to forget, that is why I want to complement what you are doing now. Let's look at NumPy slicing. NumPy slicing. So we did this in the, I think here when we talked about lists and orders on our previous classes, but it is now turned for NumPy. Okay, so array slicing is the process of extracting a portion. When you talk of slicing, it's take a portion of extracting a portion of an array. Okay, so what does that mean is that with slicing, we can easily access elements in an array. And how we do that? It can be done on one or more dimension array in NumPy, just like what we first did for one dimension, 1D array 2, and we look at the 3D. So for that, the syntax you look this way: array, which is your variable name, variable name of your choice. When we talk of indexing, this we use this to access that the square bracket. So to do that, we have to the start index where it will start. Since you're accessing a portion, the start index. After that, we use colon where it stops. And if you want optional, you might want a step by a step. By that step, I mean maybe you could have something like this from here, and maybe you have a step two. What that means is that it will give you one, leave two, and print three, and like that. So it will not give you one, two, three, but it will give you one, three, leave here for maybe if there was another item there, it's print out. So like I said, of course, the start is the index of the first element to be included in the slicing. Starts equals to index of the first element to be included in the slice. So what again? We have the stop where it will stop. The stop is the index of the last element. The last element. But note that it will exclude the particular element, the last one. Exclude. I'm coming to explain that. Exclude. What that means is that if we have something like this, if we have something like this, I could tell it give me from index one to give me from the index one to the fifth index. Okay, so this five will not be included, it will stop at 4. So that is why I'm adding this element excluded. You get to see when I experiment with it. And lastly, the step. So this, it could be in step of 2, counts in step of 2, or it should slice in step of 3, or however you want it. So take note of this. The stats index is always included. But the last element where it stops is excluded. But if this step is not added, it will take the default count. It will take the default step count, which is what? 1. So it is until you add this. So if this is not added, it will take the default. So now let's see how to access the portion of a NumPy array. Okay, so NumPy array slicing. I have to bold that and then get my cell. Firstly, let's create a 1D array. I could call it arc1, where I'll be assigning my array to. Okay, so I think I need more number. 2, 3, 4, 5, 6, 7. Okay, let me stop there. So now I want to slice from index 1. I want to slice arc1 from index maybe 2 to any index of my choice, to Let me see, 1, 0, 1, 2, 3, 4, 5, 6. Okay, we have up to 6. So index 6. So what that means is that, let me run the code first. Print arc1, then give me from what index, from 2. Okay, our stats to what, 6 to the 6. So if I run that first, 0, 1, 2, 3. So 0, 1, 0, 1, 2. So it starts from there. And you know, this is the 6th index. This is supposed to be the 6th index, but based on the condition, it is always excluded. The last element excluded. Okay, so that is why we don't have 7. But I can add a step to that in step 2. Have you seen? So from the from the 3rd index, which is 3, and I'm passing a command that it should count in step 2. So this is 3, it will leave 4 and come to 5. Since we cannot add this, it stopped at 6. That is why we have just 3 and 4. Let me make it even more clear from the 0 index. Okay, so get to see more. So it leaves, it starts from 1. The start index is always included. It starts from 1, leave 2 to 3, leave 3 to 5. Since it stops at 6, it stops there. Okay, so let me do something even more. Let me slice my array, my arc1 from maybe index maybe 3 this time around. Up to the last. Okay, so let's print it out. Print and there's another way of doing this, of which we've been doing it in what, in list and all of that. So if I run it 4 from here, 5, 6, 7. Okay, now, so if I leave here just like this, only 0, it will give me everything. So even if I don't have 0, just this colon, it will still give me everything. But if I don't add anything here and maybe specify a particular index, maybe index 6, it will give me, still give me 1 and stops there. This is empty. Even if I add 0 here and run it, it will still give me everything to index 6. So you should be familiar with that. So this alone creates a copy of that, runs from the beginning to the end. So we can modify an array using this slicing. Okay, we can modify an array. Let's see how that is done. Are you tired? Don't be tired. You soon end the class. Modifying and array. Okay, so I'll take this down and then get equal to. So let me create an array, maybe num, where I'll assign my array to I'll be a bit fast here because almost the same thing. 2, 3, 1, 4, 6, 7, and let me stop there. Now let me modify it. Modify elements. That is spelling elements in the array. So let me say 9. I'll call that, and I'll pick 1, 2. Let me say, okay, the second element. Second index is 2, 3. Okay, let me say 3. Then from the third element, okay, let it be represented with 0. Let it be replaced. Let it be replaced with 0 from the third element. So if I print num, I print num, you see that from the third element, everything will be replaced by 0. 0, 1, 2, 3. So from 4 to the last, everything is replaced by 0. Okay, I could decide to replace all of them, can modify that with 0. So you can modify a string. Okay, can we add a stop to that? Let me say to at 3, let it modify the first 3 elements for us. The first 3 elements is 0. So we see when we modify some parts, everything, and we add a stop to that. So what if I say from, let us start 1, 2, 3, 4, 5, 6. Okay, let us stop at the 5th element and let it start at 1. So from index 1 to the 5th one is 1, 2, 3, 4, 5, which stops here. It should be replaced with what? It's 0. Okay, so I can add more number here to give it a step. Let me leave 3, 9, 10, 11. So I'll add a step now. And let me start from index 0 to index 6, and in step of 2. Okay, so if I run that from the first one, leave, what are we replacing with 0? So it should stop at the 6 elements, 6 index, rather 1, 2, 3, 4, 5, 6, which is 7. So in step of what? Step 0. If you're confused, you can ask question. I'm being asked because this is what we did. We've been doing it for, this is for NumPy. So what if I access from negative index, like from the reverse? Okay. 1, 2, 3. So from 9, which stops at 7, this is 4. So from 3, it should be replaced with 0. So
I have a question.
You can go ahead.
Please go back to the previous one, 062. No.
Yeah.
Yes, change it to 062.
062. It's already at 062.
Yes, 0:6:2. Where the cursor is now before you print. You want it to start from index 0
to index 6.
To index 6, step 2. That's what I want.
Come again. I don't seem to get your question.
The one you just cleaned off in this line. Num.
Okay, sorry. Yeah, okay. So I should make it what?
Make it index 0. You're starting from 0, right?
Okay.
And then
what?
6.
6. Okay.
And 2.
Okay, in step of 2.
Yes, please run it again.
Okay.
So what happened here? It started from the first one. It started from index 0.
Okay.
And at every step.
This is 1. It leaves 3. It leaves this one. Then gets to the next one. It leaves 4. Replaces with this till when we get to a particular index we want to stop.
Sorry, 0, 1, 2, 3, 4, 5, 6. So if it's supposed to stop, it's supposed to stop at 9 now.
2, 3, 4, 5, 6.
Okay, it doesn't take the last one.
It doesn't take the last one. Okay. So if this is 6, it should stop before that, before the last element or item rather.
Okay.
Are you cool with that now?
Yes.
Okay, so I was trying to do something different. Let's do it in reverse, like negative indexing. Is it up to 5 index? I think it should. Okay, so let me pick 5 from 5 to maybe to second to the last. Okay, so from 5 to second to the last. 0. This is rather when counting from when using the reverse index, it starts from 1. So 1, 2, 3, 4, 5. Okay. So the start is always included. So from here, it will replace to 6 to the last 2 elements, which is 10, and is not always included. So that is why it's replaced with that. Okay, so I think this should be our final example. Let me just do this one. I'll add for the negative indexing, I'll add the start, the stop, and the step. So let's be at -1. I will leave. Okay. I'm doing something very quick now. You need to see it looks confusing. And to let's say -2, anything. Okay, so can you come and go ahead and tell me what's the logic at this particular line, this num, using the results?
Okay, so it starts from -1 and it's from -1 to the end from the beginning. Then step -2, so it will start from the end again. So it will pick it starts from -1, so it will start from that -1, which is 0, replace it with 0. then it will leave 10 and replace the next one, because that is like 1, 2. How me I take it that I pass the first one, and I replace the first one. The next one is 1, the next one becomes a 2. So on that particular 2, it changes it to 0. Then 7 is now the next one. So it passes that one. It passes that one and then counts again. Why is it like something is confusing?
It's not confusing. It's at step 2. So it will omit
Take
1,
care of the whole
omit 1
the
and
whole
take,
array.
yeah. So if, okay, let me do it this way. Let me even take that out and use numbers. So this shouldn't be confusing now. So what this line does, that it slices every other element of the array from the end. Okay, so you need to use experiment that using the start, the stop, and the step. Okay, so we have a very long class today. We're supposed to stop by 1. This is extra 32 minutes. We call it a day today, and we will see again either on Saturday or on Tuesday, based on the group decision. So for that, we have to call it